Okay, if there are no further questions, so what I wanted to quickly conclude in the last couple of minutes, and then I will leave the time for Professor Spencer and Berker to chat with you. So Stefan, so we cannot make object out of abstract class, but can we still have a pointer? Exactly, Stephen, right? This is what we had in our point example, if you remember, right? We created a pointer of type point, and then we pointed it to the child class, right? That's really what happens. Okay, so a quick recap of this overriding versus overloading thing. Function overloading is we had, and it in fact is as a concept that is orthogonal to object-oriented programming, right? Remember, function overloading means I can have the same function name, but I change either the number of input parameters or the return value or the type of the input parameters. I change something in the signature of the function, but I still keep the same name, right? And this is called function overloading. So the meaning is that more than one method share the same name, but have different signature. That's the key of overloading, right? Compare this to overriding when in fact the signature for the overriding methods is just exactly the same. Same name, same return value, same type and number of input parameters. Good. Overriding compared to overloading is tightly coupled with inheritance and object-oriented programming. It's not orthogonal to it. You cannot really have function overriding unless you have a child class and a base class, right? The main behavior that is intended for overloading or the use case is you want to add or extend the method behavior. So I give you the example of if you want to add or divide integers versus divide doubles, etc., etc. You might have the same divide method, but with different input parameter types. While for overriding, you want to change existing behavior of a method, which is basically in your child, right? Generally, overriding is related to dynamic binding, as we have discussed in today's lecture, while overloading is completely compile time. It's completely static, right? Here, inheritance is always required. As we already said, it has nothing to do with inheritance and overloading. Method signature, this is a different signature definitely, because you have to change something in the signature of the function. Here, it must be the same signature. And then finally, for overloading, it's a relationship between methods of same class or same scope. It doesn't really matter. It's again orthogonal to inheritance and object-oriented programming. While overriding, it's a relationship between methods of a superclass or a parent class and a subclass or a child class, which means it requires at least two classes that have an inheritance relationship between them. Overloading again has nothing to do with this. And here, just a very quick example. In one class, I'm defining two functions with exactly same name, but different signature. One of them is taking one input parameter, the other one is not. One example that we have seen already in our point class is in the constructor itself, because we said constructor is a special function. In the constructor, you can have a constructor with different number of input parameters, right? We said empty constructor, the default one, and then the initialization constructor and the copy constructor. All of this is an example of constructor overloading. While for overriding here, well, just exactly same signature in the base and in the derived class or the child class, but you override it, right? Again, we have seen many of this in today's lecture. Good. So finally, what we'll do next lecture on Friday is we'll try to apply abstraction to our lab example, which is using linked lists to implement a set. So I will just say thanks, everyone.